Hello everyone and welcome to my UDK tutorial series. It's been a while since I last uploaded one of these videos, but here I am again doing another video, so that's cool. And let's see, we are going over the UDK Cascade Particle System Editor, which is essentially the editor which will allow you to edit particle systems. Ta-da! Big surprise, I know. But essentially a particle system, if you don't know, is just a group of 2D sprites that are being animated depending on attributes that you set up in the particle system. So let me grab one of these real quick to show you sort of an example. I'll put the one that we're going to be working with a lot in the level to show you just sort of what a particle system is if you don't know. And like every video, I forget to go off of Steam. Okay, there we go. So here's a particle system. Basically, it's just fire with some smoke effects as well. And you can actually see if we move this around, it doesn't like disappear instantly. The particles still go. It's just these are being emitted from wherever we stick this. So that's kind of an important thing to note, because particle systems have a lot of interactivity with Kismet and Matinee. There's actually an entire Matinee track specifically for particle systems. So these are, you can easily, turn them off, turn them on, move them around and whatnot within both of those programs. So it's very important to note that whenever you do move these, they don't instantly go away. There's some residual particles that continue doing whatever they were supposed to be doing, because what this particle system does is you position it, and this symbol right here is the emission point. It's basically where it's emitting from. Now, obviously, it's not going to be an exact point, because it's just sort of a general guideline of the entire system, because you could have all kinds of things happening. In this case, the fire, it's just pretty, it's coming from a singular point. But if we had something like, let's see, if we had something like these leaves here, you don't really have a singular point that the leaves are coming from. This is just sort of hanging out in the middle here. So it's just kind of a general guideline as to where the particle system is occurring. But just, keep that effect in mind, because you can use this for something like a train. If you have a train, it's like a coal-powered train. So you've got steam coming out of a smokestack, and it's just heading down the track. Well, you just stick a particle system inside the smokestack and just have it constantly emitting and moving with the train, and the smoke will move like you want it to above the train. Because the particle system's getting moved, the particles are getting spawned along with the train, and the smoke just kind of comes out from behind it as the train moves by. So, that's just kind of one aspect of where you can use that to an advantage. It can sometimes be a disadvantage if you don't want residual particles appearing, maybe inside of an object if other objects are moving behind it, but you'll just have to design your particle systems to work around that. So, anyway, enough of that. Let's get inside this and start playing around with them. So, alright, to get to this, obviously pretty simple. Double click on a particle system, right click on it, and just select Edit Using Unreal Cascade, or you can right click Empty Ground, go to New Particle System, make your own, name it, give it a package name, and just click OK. They'll all bring you to the same menu. Let me open up the Fire. Oh, before I get started, real quick, I want to say, I've had some issues with UDK crashing randomly. I apologize if it does so. I'll just bring it back up real quick and we can begin again. I would edit it out, but because of the way that I'm having to record these tutorials at such a high quality, it takes a long time to render it out if I try to edit it. So I just have to kind of leave them in the raw file. So just bear with me. And again, I do apologize for the fact that it's crashing, but I don't know why it's doing so. Hopefully it won't. I think I fixed a problem, but I won't know until it crashes again. So, alright. Anyway, that aside, let's go ahead and talk about this interface here. It looks complicated. I thought it was rather complicated looking the first time I pulled it up. but it's really not very complicated at all. It's actually more, it's probably one of the simplest windows to work with in any of the programs in UDK. Probably even more simple than Kismet, because Kismet has all the nodes and stuff. It can be kind of confusing wiring everything, but this is really self-explanatory. In fact, this entire top bar here doesn't really do anything to the particle system. It is primarily designed for allowing you to change how you're looking at your particle system, but from like an editing standpoint. For instance, we can add grids. So stuff like that, adding grids, like changing the background color so we can see how it looks in different places. Wireframe sphere, that's fine. So we can kind of see like the bounding box of different areas of the particle system. You know, we can do all that kind of stuff. We can toggle whether it's looping or not. You know, so we can turn that on and off. Play, pause, set the simulation speed, all this kind of stuff. And you have a lot of stuff to do with level of detail and whatnot. And this button right here is very useful. It's save thumbnail image. So I'm not going to do it, but if I click this, it would take a picture of the simulation as it looks right now. It would like literally pause it, take a picture, and play it again, or something like that. And then it would assign that to this file. So right now we have a picture of this fire. Well, that's the thumbnail image. Some of these don't have an image because no image was taken. But all you have to do is just go into it and take an image. And see, some people change the background color so it would show up better. And different things like that. So you can kind of change things up to get a better image if you want to. And all that kind of stuff. Toggle motion. There's all kinds of things here that you can just kind of, you know, hover over and it'll tell you what they do. It's pretty self-explanatory. Not too much there. Edit. These two things. Save package. Regenerate lowest level of detail. Fairly self-explanatory. View. This is fairly useful. Some of these aren't as useful as some others, but the particle counts actually have on, so you can kind of keep track of the number of particles that are being spawned from each emitter in the particle system, which I'll get to in a minute. But you know, you can just kind of click these different things. It'll just start popping up numbers and, you know, different graphical stuff all over the place to allow you to sort of see real-time feedback for your particle system. And then, of course, window. We have 3 different windows that we can kind of look at. I have the Unreal Curve Editor disabled at the moment, but the other 2 are enabled. So, which is this is the preview window, and this is the properties window down here. So if I disabled that, we just have these 2 things. If I disabled preview, we would just have this. So it's entirely up to you how you want that. But anyway, and you know, this all can be moved around and sort of custom tailored to however you want it to be. So just keep that in mind. Alright, so next step. Let's see. Okay, so this of course is the preview menu or window. And to move around in it, it's like most other stuff in UDK, left mouse button to sort of pan around and over and all like that. And then right mouse button to zoom in and zoom out. Middle mouse button will allow you to pan around like that. Now, one thing that's very easy to do when looking in this menu is to get lost. Like right now, if I just kind of turn around and do like this and stuff, I don't really know what my original orientation was compared to what it is now. You know, if I'm looking at it from the other side, or, you know, the north side, the south side, or whatever side I'm looking at, I don't know. So it'll be hard to sort of tell, just looking at your particle system, sort of what side you're looking at, which is why this thing down here in the bottom left corner is so very useful. That way, looking at this will allow you to, you know, sort of know exactly which side you're looking at, because if you want particles to be traveling along the x-axis, and you're looking at it from the y-axis and particles are moving, then you have a problem, because they're not moving on the x-axis, they're moving on the y-axis. So you want to kind of keep track of the positioning that you're looking at this thing from, because this will just orientate to show you exactly the way that this is that you're looking at this from. So this little tool down here in the bottom is very, very useful. So just keep an eye on that whenever you're moving around in this thing. Next we have, of course, the modules window. I don't know if that's actually what it's called, but that's what I'm calling it. It's sort of the modules emitter window thingy. If you right click in this black area, you can get a new particle sprite emitter. You just add that in, and then you just basically put your texture in there and then just start adding stuff and you get a particle. That's what they did here. They just added some textures and they just started adding various attributes and these little module things to this to get the desired effects. So we'll delete that. And you can have as many of these emitters as you want. Excuse me. You can have as many of these emitters as you want. I mean, I can scroll through here and there's a bunch of space. You know, I mean, this is expandable, of course. But you can really have as many of these as you want. I don't know if there's a cap. I haven't really tested it because you'd have to put a lot of these in here to reach, you know, all the way to the end of this. But for the I mean, if you're having to use that many emitters in one particle system, you should really split it into more particle systems. But anyway, as far as memory is concerned, having 2 emitters in one particle system versus 2 particle systems with 1 emitter each doesn't really matter memory-wise. It's still having to do the same amount of calculations. It's just that they now may or may not be harder to work with, because in Kismet you may have to add 2 sets of tracks instead of 1 set of tracks. So realistically, if you can put multiple things in one particle system, do so, because it's a lot easier to work with in Kismet and Matinee. Yeah, Matinee has the tracks. That's a movie editor. I always get my words mixed up. It's a lot easier to work with in Kismet and Matinee if you just have 1 particle system versus like 3 or 4. But at the same time, sometimes you can't accomplish what you want to accomplish using, you know, in the same particle system. You just need a separate one. So that's entirely up to you, but as far as memory usage, it only really comes into effect whenever you have a lot of actual particles being spawned. It doesn't matter the number of systems or the number of emitters. I mean, technically there's a little bit of additional code involved in a system versus an emitter, but it's not actually affecting the actual calculations for the what's it called? Words. It's not affecting the actual calculations for the GPU or the CPU, because that's what's having to be doing the calculations to figure out what the positioning of the particles should be. So if you have 1,000 particles in one emitter versus, you know, 100 emitters with 10 particles each, yeah, that's 1,000. So, you know, if you had 100 emitters with 10 particles each versus 1 emitter with 1,000 particles, it would be roughly the same amount of memory being used to calculate all of the number of particles, because it's not the number of emitters but the number of particles being spawned, which is something you want to look out for, because if you have too many particles being spawned, you will start getting lag. Particle systems can be very expensive on the GPU because it's having to take each little bitty sprite and extrapolate movement in 3D space. Not only is it having to, you know, make it look like a 2D sprite look like a 3D object, but it's then having to extrapolate that movement, and if it's got a fancy material on it that, you know, has lighting, it's having to, you know, then calculate the lighting and all of that stuff for each little particle all at the same time and constantly. It's not just like do it once and you're done. It's having to do it constantly, and it's not even something that you could like render pre ahead of time and then play sort of like a cinematic clip or something. It's completely randomized, which is what makes a particle system a particle system. That's the whole point, is for it to be randomized, so it's not the same thing every time. It looks different and fluctuating, like this fire. So just keep that in mind whenever you're designing them. I know it seems very simple, very trivial, but just memory is an important thing in games. It's always something that people are having to look out for and be careful about, because you want people to actually play your game, not play your game for about 5 minutes until your computer pukes and attempts to disconnect itself from all aspects of that game, and it starts deleting files because it doesn't like the fact that it has to work so hard. You don't want to kill your computer, and be the cause of mankind's downfall in computer revolutions. Okay, so basically, if you don't want to kill mankind because of a robotic uprising due to the fact that your game is so hard on computers, work with the memory. Okay, make sure that you're okay. That didn't come out like I wanted it to, but whatever. Moving on. If you click on one of these things, you get a properties window at the bottom. That's pretty self-explanatory. You have a cascade thing down here, but that's in every one of these, so don't worry about it. You can actually change the color of this, and it'll change like the little color over here, right? Which also corresponds to the numbers, which I have the particle counts down here. So it corresponds to the numbers there, so you can kind of look at that to see which emitters have which particle numbers. To determine which one is bigger, it's basically the one that has more particles. So that's why the blue one is bigger than the purple one. It just has more particles in it. Alright, so really the main step, sort of what I'm going to be going over the rest of this time, is just sort of some basics of how to create your own particle system. But I'm not going to go over every module, because if I right click here to show you all of the modules, there's a lot of them. And going over every single one of them in detail would take a long amount of time. Plus, I also don't know what every single one of them do in detail. I have the general idea, but, not really enough to just say, hey, this does this, and then move on. I don't want to just say this does this for like 5 seconds and not give a detailed explanation. So I'm just going to go over some of the basics on how, you can edit stuff and make things look cool, and then just leave the rest up to you to experimentation. Because really, whenever you're making a particle system, what you need to know is what it's going to look like before you start working on it. Now, yes, it's true, you may change your mind as you see what it looks like, and you're kind of just playing around with numbers, but you have to come to the table with some general idea, so you can kind of know what you need to apply to the particle system to get it to look like that. For instance, if you don't want the particle, if you don't really want the particles to move a lot, you're not going to need a lot of velocity. So you may not need this, initial velocity thing. You may not just need to spawn them in. They grow in size or shrink in size and then just pop out if you don't need them moving. But if you do need them moving, then you will need initial velocity. So that's just kind of, an example of that. But let's kind of start with the required, because the required and spawn are always going to be there. So you can see that whenever I click a new emitter, it gives me lifetime initial size, initial velocity, and color of a life. But technically, I get rid of these 4, and I only need at least the required and the spawn for this to work. And it'll spawn them in. Now, if I don't have a lifetime, they won't have any way of dying, and as you can see, over time, this number is just getting larger and larger and larger and larger, and eventually it might crash. So let's delete this really quick before we have issues. So that's just kind of something you want to keep in mind, that you need some sort, you don't necessarily have to have lifetime, but you need some sort of way of getting rid of the particles once you've spawned them. Unless you just want to like turn on the particle system for a couple seconds and then just turn it off. I mean, you could do that, but you just have to have some way of getting rid of the particles. There's actually collision, or I'm not collision, kill. So you can set a kill height or kill box. So the leaf example that I showed earlier, I think I showed it earlier. I've tried recording this tutorial several times. I'm getting my things messed up. Let me just bring it back up, just to make sure. Okay, so if you look, there, let's see. Okay, no, they don't actually have it in this. I thought they did. Maybe it's in the other one. Is it? It is not. Okay. Well, I thought that they had these in the leaves, but they don't. But basically, the way the kill box or kill height would work is that once the particles hit that certain point, they get deleted. So as long as you set like a velocity, you could set them so that at least as long as they head towards that kill position, then they'll get deleted, and you don't technically have to have a lifetime. But, you just, again, you need to make sure you have a way of getting rid of your particles, or you will run into some serious problems very quickly. Alright, so let's click back on this, required. So we have the material. This is basically where you go to select the material you want to use. Speaking of which, I always get sidetracked. Find this. Okay, so find that material. I'm going to open this real quick and show you something. You can see that the material isn't really very complicated. You don't have to have a complicated material to work with a particle system. And really, you only need at least one of these things. They have a couple of them to make some stuff work, which I'll explain in a minute. But you only need at least just the texture. You don't really have to make a complicated material if you don't want to. But you can. So, if you wanted to do so, you could make a material that glows in the dark. The fire, I believe, it does show up in the dark because it's orange, but it doesn't actually produce light. It is appearing there strictly because the color is orange, and you can see it in a black background. But if you have a material that actually does physically produce light, you could have those animate and it would light the surrounding area. So that's something to keep in mind as well that you can do with these particle systems. This is not only just a particle system, but also the materials you're using. Now, one thing that is necessary if you want to fiddle about with the color over life module, if you want to be able to use this, you need to make sure that you have a vertex color node, which is plugged into a multiply. Which, it doesn't have to be exactly like this. They have theirs set up in a slightly different way. But as long as you have I'm not going to go into the complicatedness that is material editing. I don't fully understand how it all works, because that's more of an artist's job, and I'm not really an artist. But basically, as long as you have your vertex color and your multiply, you just kind of plug them in similar to the way this is set up, and you should get something working that you can kind of mess around with the color over life. Because by default, it doesn't really, just plugging a simple image in there, it doesn't really have anything to be able to reference to change the color through. Basically, adding these two things to multiply and the vertex color allows the software to have sort of a mediary of a way to change the color, because it can't really affect the base image. It has to have something that it can go through to affect the base image. So hopefully that makes sense. Anyway, okay, close that, bring this back up. Again, I apologize for if I'm rather vague on the way the materials work. I don't really understand it. I just read an article that says you need to make sure that you do this if you want the color over life to work. And I'm just like, okay. They didn't explain why. It's just said okay. So, anyway. Now, let's go back to required. Okay, so we have material. You've got, I'm not going to go over all of these, but you've got just a whole bunch of different options here. You can code various particles based on distance if you want to. So there's another way that you can get rid of particles. Duration, delay, you can set up all of these different things, and you can do stuff with rendering if you want to, fancy stuff. If we go down to spawn, this is sort of some interesting stuff that you can mess with. So right now we have a constant number of particles being spawned, and you'll notice that the number of particles is 15, but the constant value is set to 5. Now this is basically 1 every second. Okay. Well, okay, it's 5 every second because it's set to 5, but it would be whatever this number is every second. But if it's set only to 5 every second, then why are we have 15 being constantly emitted? The reason for that is the lifetime of these is set to 3. So because they're being emitted and they're living for 3 seconds,
and that's constantly happening, by the time that the particles start dying, you've gotten up to 15. So if we were to stop this simulation, or just restart it, if you watch 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I was a little late. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 there. I can't count quite that fast, but anyway. So then once it hits 15, it's staying static because one will die and a new one's being spawned. It's just constantly happening. So basically your lifetime it's basically the calculation is going to be spawn, whatever this number is, times the lifetime. Now, for the lifetime, you see you have a minimum and a maximum value. So really, you're not going to get a good number of how many particles you're going to have if you have two different minimum and maximum values, because it's going to pick a number between those two numbers and assign that to a particle. So if I were to do something between 1 and 3, you're going to see something very different. Now watch this. This is not going to be static anymore. It's going to be fluctuating constantly. Because sometimes a particle is born that lives for only 1 second. Sometimes a particle is born that lives for 3 seconds. Sometimes 2. Sometimes 1.1479783. Sometimes 2.87643. Nobody cares about these numbers anymore. So it just picks random numbers between those two values and assigns it to a particle. So you're not going to get a constant fluctuation. So really the math behind this would be the number of particles you would really have would be the average, of those two. Sort of just basically a number in the middle would be a good guess. Because the average technically would just be every number, which is an infinite amount of numbers, and math, which nobody is going to care that much about the deep math behind this. But anyway, if I changed up the spawn count, you'll see a larger fluctuation. Now you see larger fluctuation because more being spawned every second, so therefore more have an opportunity to have different numbers. Okay, and you're seeing a lot of 20 and a lot of 19, but it's jumping really fast between all of them. So you can see, 21, 22, 23, 22, 21, 20, 20, 19, 18. It's just jumping between all of these numbers very quickly. Okay, if I turned it up to like 100, we're going to get a lot of fluctuation. So you can see a lot more fluctuation. Okay. So, that's that. Now, if you're watching, you kind of saw a huge difference between the way that this fire started looking. Let me set it back down to like 5. Actually, I'll set it down to 1. If I set it to 1, we're going to get this. This does not look like a fire. It has a fire texture, but it doesn't look like fire because fire is coming forth from an object at a constant rate. Usually, unless it's starting to spread. But in this case, it would be coming forward from, a generally constant rate with some fluctuation, of course. But there's way too much space, and it's not fast enough to give us the impression that it's fire. So if I turn it up to about 5, enough particles are being spawned that it fills in all of that gap there, so it seems like fire. But it's also not too many, so that it seems that it has enough fluctuation in it, and it's kind of tilting from side to side a little bit as the wind's picking it up, because it's not static, it's burning, and so as it's consuming the fuel, the actual positioning of where the fire's origin is also changing, so it's not going to stay in one spot. Now, if we turn it up even more, we get it starts to look a little bit more like fire because even more gaps are starting to be filled in, and you're starting, as you increase the particles, you're going to start getting, they actually use a very special texture the way that they set it up, so the particle changes over time. It's using this sub-image index thingy-majigger to do that, by the way. This is the module that's controlling the way that this is able to change the image as it progresses. Because if you look at the picture here, we have a lot of different pictures,
and it's just changing the longer as it's living. It's just changing the way that the image looks. But let's see. So as we have 10, because the center particle is like this white almost thing, the center starts to look more and more white because we have more particles being spawned in that one spot and are staying there for, you know, a longer amount of time. Well, they're not actually staying there for a longer amount of time, but we're having more spawned each second to fill in the gaps of when they're not there, if that makes sense. And because of the way the opacity is set up on this, technically you would be able to see some stuff through this. You can kind of, you can't really see much through the black, but that's also one reason that's affecting this, is it's overlaying all of that opacity on top of each other to where it's not really being opaque. It's not becoming transparent, it's becoming opaque. So if I change this up back to 100, now you can see it's almost becoming slightly hard to look at because it's just this constant white glow. And this looks really like a fire. I mean, this looks really, really nice. We would have to up the smoke a little bit and probably change it up so it's fluctuating a little bit more to the sides to kind of fill that whole area out a little bit. We would have to make some changes for this to be finished, but this looks a lot more like a roaring fire. The one before it was just sort of like an idle campfire. This is more of a roaring fire. However, notice the particles. We're at like 300. This is just 2 emitters. And this actually doesn't even take the smoke into consideration. If we were to do the same thing to the smoke, let's see, it was at 5 before, and I changed it up to 100. So 5 will go into 100 about 20 times. So 20 times 2 would be 40. So that's the same ratio. So, no, that doesn't look good. Let's do 10. Actually, 5 probably be like 7. That's about good. I'm not going to fiddle with it too much. So now we've got about 328 particles altogether. And I mean, that's just a little bit of tweaking. We would have to do a lot more tweaking to get this finalized. Okay? But that's 328 particles constantly for one particle system of fire. Now, usually, if you're going to have a fire like this, you're going to have a lot more fires. So, if you have, like, I don't know, 3 of these, that's going to be about 1,000 particles already, with just 3 of these, without even considering particles from weapons and other stuff like that. So, while it looks cool, you also have to be very cautious because they add up fast. So, the rule of thumb is if it's looking really, really awesome, you might want to check your particles because you might have way too many. So, anyway, I already talked about memory. I'm gonna try not to dabble on it. But okay, let's undo everything we've done just now. Okay. So now, if you set this to 0, what's essentially going to happen is it's not going to spawn anything. Zeros, it's not going to spawn anything at all. And you can go down to this burst, and you click this little green check or plus thing, and you can set up a burst event. So if we do count of 1, count low, let's see, time at 0. So what this is doing is this is bursting, right? Now, the reason it's doing it at a regular interval is because we're having the system loop. If we didn't have the system loop, it would just burst once. Well, it should only burst once, but it's bursting multiple times for whatever reason. Okay, if I set this to 5, now it's not wanting to work like it should. Essentially, you can set up like a burst, so you can have something for like set up for like weapons, where you can have like muzzle flashes or something. Since muzzle flashes aren't going to constantly being emitting, they're just going to emit every time you fire. You just want a single burst particle. That's it. You just want one, and one single burst. And the reason you would use this as a particle system is because it would be randomized. So, the rotation or the intensity or whatever would be different every single time it occurred. And because it's being done rapidly, it would give an impression of fluctuation. But it's not continuous. It's bursting. I could bring up the example, actually, because for some reason mine's not wanting to work like it's supposed to, even though it was working before. So this one, it's playing right now. But if I restart, you can see, I'm just clicking the restart button a whole bunch of times. And it's one particle being spawned. Rotation is changing, right? And all that kind of stuff. It's just randomizing the rotation. But that's all it's doing. Okay. Now there's a lot of stuff over here. But really it's just lifetime, initial size, initial location, and the mesh rotation. Okay. And all of this stuff is just necessary just to give it some basic properties to stay in one spot. And it's just doing a burst. So if I go to spawn, you can see that we have basically the same things that we had before, but for some whatever reason this is not working. So this is set to 0, 0.1, and I guess they've got some other option check somewhere that I'm just forgetting about. But anyway, so that's sort of what the burst will allow you to do. You'll just need to make sure that you set your constant to 0, because that defeats the entire point of the burst. If you have your constant on all the time, you won't notice a burst because it's just always emitting particles anyway. So, anyway. Okay. If we go back down to the fire, bring this back up. Let's undo all that stuff. Okay. No, I apologize. Okay. Now, let's see. Lifetime, pretty much went over that. Initial size. This is just going to be the size of the texture, basically. If I set, and again, you're going to need to make sure that you keep track of the orientation of things, because we have X, Y, and Z values. You're going to be working with these a lot whenever you're working with these particle systems. So, for instance, if I changed all of these values to 0, 0, 0, that's basically going to cause this to happen. Now the values could be anywhere. No, wait, I got it backwards. I done goofed. There. Let me close this out. It's all messed up now. Nah, it's still there. Okay. I set the wrong ones. This is max. Max. This should be set to 0, 0, 0. So now you can see in there's some tiny ones. Let me set this. Yes, and then we got a group of smaller ones. We're getting like some really small ones, some really big ones. If I set these all to like 50, it'll reduce the entire size of everything. So now you can kind of see a little bit better. But this is happening in every direction. And right now I've got it set equal. But if I were to do something like this, and I had, maybe 1,000 for the Y, okay, that's not spawning. I have to have at least one. It's not showing up at all. So if I look at the Y value, it should stretch it, because I've got a value for the Y, it's here. So let me set that like that. It should be, because which is why I'm wanting to get the orientation. It's not wanting to do what I want it to do. I guess I could look at it like this. See. Now, I'm not getting an effect change. Okay, that's fine. That then just be obstinate like that. Velocity would be easier to show. Let me exit this, open it back up, because it's an easy way to set my changes. Okay, velocity. So
this will be an easy way to show what I'm talking about. If I set the velocity to be like 100. So now we can see the velocity changing here. But if we look at it like this, it's not all that easy to tell. Now obviously it's somewhat easy because we haven't going that far. If we set this down to like 20. You're not really going to be able to tell that they're coming towards you, although they technically are because they're going along the y value, but we're looking along the y value, so we're not going to be able to tell that. How if we turn it, now we can sort of see that they're moving along the y value a little bit more than they were. Let me do like 50, and then so they're going this way. Turn it back here. Again, you can't tell it that easily. They sort of look like they're just getting, they're sort of going a little bit this way. So really it looks like they're going to the x value, but that's just because of the perspective. So that's just kind of one thing you want to keep in mind. If it's not if you're not seeing any changes, you may just want to like move so you can get your camera where you can kind of see both angles on it. But anyway, so obviously velocity, that's what I was going to get to next anyway. Velocity, one thing that I thought whenever I first saw this was I was thinking sort of in terms of speed, but velocity has nothing really to do with speed. It's more of a direction, right? So at least in this case. So for the velocity, you're giving it a vector on which it's going to be traveling. So it's going to pick random XYZ values and have it travel basically in that direction, a diagonal path or a straight path or, side-to-side path, whatever, vertical, horizontal, or diagonal, one of those directions. And it's just going to travel along that. And then all of the other stuff is applied to it. But it's not going to travel faster or slower. It's just traveling the same speed as every other object. If you wanted to change the speed of the object, not the direction, you would need something like acceleration. And then usually you're going to have acceleration, and then, you're going to have, in this case, acceleration over life. There's a lot of different things. Color over life, velocity over life, all this kind of stuff. So you can have just a raw acceleration value or a raw velocity value. Actually, if I go down to velocity, you have several things. So there's a lot of different options. But the difference being basically how it's calculated. So acceleration versus acceleration over life. Acceleration would just be, it's going to accelerate to this speed. Just, everything. Acceleration over life would be it's accelerating, and then you can have it deaccelerate and reaccelerate depending on the lifetime of the object. So at 5 seconds it's going to be going this fast, at 6 seconds it's going this fast, at 7 seconds it's slowing down to here. Acceleration, just a raw acceleration value would be saying, okay, when you start you're going this fast, and when you die you're going this fast or this slow. You're just accelerating to something. However long it takes. So that's sort of the difference there, and that can be applied for everything that has an over life. It's just it's taking that value and it's applying it by another value, essentially. All right, now let's see, rotation. Let me set all of this back to normal again. Oh, okay. Undo all of this stuff. It's not resetting. Fantastic. I don't remember what it was before. That's fine. We'll just turn this off for a second. All of it. Turn it all off. Just delete it then. Fine. Be that way. There. Okay, that's what I wanted. Okay. So if we look at the smoke, one thing that would add sort of a lot more, one thing that would make it more interesting is if we could make it spin. Now, there's several things that are going to make you think that you would use spin. So you have rotation, and then there's rotation rate, right? What you're going to want to do if you want it to spin constantly the entire time it's alive is rotation rate. Rotation would just make them have different orientations. So for instance, if I add rotation here, and now if you look at the smoke very carefully, you'll notice that different versions are spawning in at different rotations. Because if you watch the orange section, you'll notice it's appearing on different sides, right? So that's essentially just our sign that this is working. Let me pan up a little bit. So we can see that, you know, it's spinning, and it's not spinning, but it's spawning in different sections. But if you want rotation rate, you get this, where it's constantly spinning over, you know, the entirety of its lifetime. So if you couple those two, you'll get this. And it'll look like it's spinning faster. It's really not. It's just that some particles are spawned pre-spinned in a certain direction, and then it starts spinning. And because the previous one wasn't that far, it sort of seems like it's spinning faster because they're passing through each other. It's just a perspective thing. It's not really spinning faster, but it sort of makes it seem like that. So those are two things you can kind of use together, where you're spawning them in with a certain rotation, and you're spawning them in with a certain rotation rate. You know, so you can use the two together. So you could actually have it spawn in rotation rates in a certain direction, and then have the rotation rate opposite that to give like an optical illusion. It'd be wonky, but you could do that if you wanted to. Okay, so those are some other sort of things that you can use in doing these. I think that's about all I'm going to go over with the particle system. Again, I'm not going to go over all of these because they're fairly easy to figure out. You just kind of place it down and just fiddle with the settings a little bit. They're all pretty simple and similar. You're either going to have a minimum and maximum value, and you just enter that. And, you know, for this rotation rate, it's just going to have, you know, a minimum of rotation in one direction and a max in another direction. You know, so some of these are actually spinning backwards, some are spinning forwards. And then, you know, you can minimum max in this case, so this is just going to say, you know, 0 between 1, just sort of like a degrees, if you will, of the rotation, sort of where this position, you know, of initial velocity, you're just going to have XYZ values, but it's the same concept, a minimum and maximum values. Just remember that with the velocity, you can set negative values. So if I set a negative value, it would actually go, you know, to the left. If I set a positive value, it would go to the right, looking at it like this. That may not, you know, translate if you turn the camera at all. Like if I turn the camera really at all, it wouldn't be necessarily going left and right. But just remember that you can actually set negative values. Usually your minimum will be negative and your max will be positive. You know, if you wanted to flip that and make it more complicated and confusing, you can, but it would just be weird. So just keep that in mind. But that's pretty much it as far as particle systems go. Not too complicated. You know, I got to get 48 minutes out of this, but you know, hopefully it's all made sense to everybody. If something didn't, I would like to know so that I can, like, you know, go back, re-record, and fix it. I've tried recording this tutorial like many times, but I'm sure I'm still missing something or doing something wrong somewhere. But anyway, feedback is of course much appreciated, and yeah, I'll see you all in another video. Thanks for watching.